In this video, I am going to do a series of calculations for the normal distribution. We are really going to do two different calculations using either norm.dist or norm.inv, alternatively norm.s.dist and norm.s.inv for the standard normal. The standard normal has a mean of 0 and a standard deviation of 1. And I'll show you the connection between these two things, which is through the z-score. So, in this first example, we're going to try to find the percent of observations in the normal distribution which are below a particular level. So here we've got an example. We've got a mean of 3, standard deviation of 5, so that defines our normal distribution. And we want to know what percent of observations are below 1. Namely, what percentage, if we started doing random observations from this distribution, what percentage of those would be below 1? All right, so this is going to be using the function norm.dist. We put in our observation, the 1, the mean, 3, the standard deviation, 5, and then true for the cumulative distribution function. So this is going to return the probability, 34.46, of an observation being drawn from the normal distribution with mean 3, standard deviation 5, the observation being below 1. Now, an alternative way to do this would be to compute the z-score. So that is our observation minus the mean divided by the standard deviation. How many standard deviations away from the mean are we? -0.4. And then we can use type norm.s.dist of our z-score, and again true, and we should get exactly the same answer. Okay, our next example, we're going to calculate the percent of observations above. Again, we've got a normal distribution, mean -1,000, standard deviation 125, and we want to know the observations above -1150. Now we can do this in two ways with norm.dist or norm.s.dist. I'm going to just do the norm.dist variant. And we know that if we do norm.dist of our observation, the mean and the standard deviation, and true, we're going to get the percentage below. So we simply want to do 1 minus norm.dist of the observation, the mean, the standard deviation, true, and we get the percentage of observations above this level. Okay, we can do the inverse of this exercise. We want to find the level for which a certain percent of observations are below. Again, we've got a normal distribution with mean 200, standard deviation 20. So we're going to use norm.inv for the inverse cumulative normal function. The probability, 25%, the mean, and the standard deviation. And we end up with 186.51, meaning if we pull random observations from a normal distribution, mean 200, standard deviation 20, 25% of those would be less than 186.51. Alternatively, we can calculate the z-score first, equals norm.s.in of 25%, and then we can turn the z-score into a level, and the way we do that is we go take the mean plus the z-score times the standard deviation, 186.51. So either of those work, they both come out the same. Okay, again, we're going to do just one direction this time. We've got a mean of 100, standard deviation of 10, and I want to know what level has 45% of the observations above. Well, if it's 45% above, it's 55% below, and so we could do norm.in of 1 minus our probability, comma, mean, comma, standard deviation, 101.26. So we're taking norm.inv of 1 minus the percent if we're interested in the level for which the percent above is 45. Okay, two more problems. We want to find the percent of a normal distribution, the percentage of a normal distribution found within plus or minus 1 standard deviation. Well, this is like taking a z-score, so we're going to use norm.s.dist, and we want to know norm.s.dist of 1, true. So that's the percentage below 1, standard deviation away from the mean, minus norm.s.dist of minus 1, true. So 68.26, let's make that a percentage. 68.27% are within 1 standard deviation. 95.5 or 45 is within 2. 99.73 within 3. Okay, last, we want to find the range around the mean, centered at the mean, for which 60% of the observations fall within. Okay, well, 60% fall within, and we're centered on the mean. That means 40% fall without, which means 20% are below this lower bound, right? Half of the 40%. So we're going to use norm.ind of 20%. So let's see, how do we calculate that? We're going to calculate that doing 1 minus the 60% over 2, right? Half of what's outside, comma, the mean, the standard deviation, 0.16. The upper bound is going to be the percent of observations. Again, we've got that 20%, but now we want 80% below, 20% above. So that's going to be norm.ind of 1 minus the 60% over 2, comma, mean of 1, standard deviation of 1. Oops, 1.84. So 60% of the observations are between 0.16 and 1.84. And we can check norm.dist of 0.16, comma, mean, comma, standard deviation, comma, true. We should end up with 20% below this 0.16, and 1 minus norm.dist of 1.84, comma, mean, standard deviation, true, 20% above 1.84. So 20% below 1.16, 20% above 1.84, which means what's left, 60% in between. I hope that was a helpful video, and there are some more problems. You'll find them in other videos on the website.